Hello, folks. Welcome to this session. Next, we have Pavithra and Frank talking about inclusive data for 1.3 billion, designing accessible visualizations. Please give them a warm welcome.
Hi, everyone. I'm Frank Elavsky. I'm a PhD student here, actually candidate now, just proposed, here in Pittsburgh, actually, at Carnegie Mellon University.
And I am Pavithra Eswaramoorthy. I work as a developer advocate at QuantSight Labs.
Well, let's jump in. 1.3 billion people across the world live with a disability. And disability is broadly defined. We look at it and talk about it in different ways. Here in the United States, over a quarter of all people self-report living with a disability that affects their daily life in some way. Disability, of course, again, can be talked about and defined in different ways. And one way that the CDC asks about disability is with different categories. So 4.1% of people in the US have color vision deficiency, 4.8% are blind or low vision, 12.8%, the largest category, is cognitive and neurological, so this includes autism, ADHD, a spectrum of other disabilities. 12.1%, the second biggest category of disability is motor and dexterity. Largely, it's the second biggest category because it intersects heavily with aging. 7.4% is vestibular and motion-related disability, which is like orientation and balance. And accessibility is work that we do towards equitable participation. And when we use the term accessibility, it sometimes can be broadly applied. Oh, I'm making data science more accessible to high school students, or broadband internet access in rural areas. But today we will be talking about a very specific type of accessibility, use of the term, which is related to people with disabilities. Why does accessibility matter is a big question, and a question I think a lot of folks here at PyCon maybe haven't asked themselves before. But I just want to say that accessibility is the right thing to do, including with people with disabilities is the right thing to do. But also, accessibility work often produces a better experience for everyone, including everyone here today. And the last point I want to make to really stress is that it is a legal requirement, and the Americans with Disabilities Act and the European Accessibility Act, two in particular, over the next year actually will have increasing regulations and expectations on folks. So this is important right now, it's relevant. And on my first point, that it's the right thing to do, people with disabilities have a right to participate in politics. And we often communicate politics through charts and graphs and maps. People with disabilities have a right to make informed decisions, especially about their health. And we communicated during the COVID pandemic heavily through diagrams and infographics related to flattening the curve and talking about rising cases and more. And lastly, people with disabilities have a right, of course, to analyze data, to get jobs working with data. And I now want to talk about this really important concept. When I say accessibility has this broad impact for everybody, including everybody here, I want to talk about something called the curb cut effect. Historically speaking, people with wheelchairs advocated and fought for cities in the United States to cut curbs. Curbs are that separation of a sidewalk and a street, and they're a raised surface, so it is very difficult for people with wheelchairs to navigate. And so the pressure was to cut curbs and to standardize how curbs are cut. And it turns out, lots of studies now have been on this topic, that cutting curbs actually makes cities safer for everyone. And this is now called the curb cut effect. If you're carrying groceries, it is much safer to take a step. If you're walking children, if you're elderly, if you're new to the city, if you're unfamiliar, curb cuts broadly make cities safer. And so this thing, the curb cut effect, is about how focusing on accessibility often impacts many other people. A common curb cut that I talk about is contrast on our phones. Contrast, automatically adjusting, brightening and darkening our phone screen, was designed for accessibility, and we all benefit. If you really want to try out using your phone on a bright day without automatic contrast, you'll very quickly learn that we benefit from often invisible designs that are accessible. And the last point I want to make to personalize this is that we will all, if we live long lives, age into disability. It's a fact of life. And so accessibility means that if we do this work, we are not just building a better world for other people. We are building a better world for ourselves someday, too. So, data visualization. I've been visualizing data for about 10 years now, professionally, almost exclusively in data visualization. I love this work immensely. I did not start in accessibility, but I started in data viz, and I really love the practice. We use visualizations to do all kinds of things. We build websites and dashboards that center around charts and graphs. We build apps that center on charts and graphs. We communicate our research with figures. We do interactive analysis in notebooks, and we even monitor and log data live as it's coming in. And the Python ecosystem contributes significantly to all these different ways that we interact with data. There's a broad spectrum of tools for visualizing data in Python, and of course, we're not going to unpack the pros and cons of how every library does or doesn't do accessibility. That's not what the talk today is about. But what I do hope is if you use any tool in Python to visualize, or you are a maintainer of a tool in Python, we really hope that what we cover today will be very relevant to your work. And I also want to say something about Python in general. Python is a pretty high-level language, and it is not tied to very accessible materials. Accessibility work requires a pretty low-level understanding of the building blocks you're creating things out of. A PNG, as a building block, isn't very accessible. But HTML on the web is. So we'll unpack that a little bit more later. And as an introduction to accessibility, I just want to talk about standards. There's a lot we could talk about in accessibility work, but this is where most professional work in accessibility is situated. People have jobs where they do work on accessibility and analyze things, do evaluations, et cetera. They focus on things called standards. The leading standard is the Web Content Accessibility Guidelines, also abbreviated as WCAG. And navigating WCAG is, ironically, pretty inaccessible. And so what I did is I compiled standards, accessibility standards, and research on accessibility related to visualization, created a framework, a tool, if you will, called Chartability that helps people evaluate charts, graphs, and interactive data experiences on the web pretty systematically for accessibility. And so we'll be talking largely about chartability and then chartability in context applied. So there are principles in accessibility work. The Web Content Accessibility Guidelines has a lot of tests you can do. Chartability has 50, for example, 50 things to look out for. So it's not a top 10 list or a top 5 list of things you should do to make visualizations more accessible. It's very comprehensive. But all of these tests are organized in a hierarchy underneath principles. The principles are perceivable, operable, understandable, and robust, and those 4 come directly from accessibility standards. Chartability also has compromising, assistive, and flexible. And these principles should really be the main thing that drives thinking about design on accessibility. Whether or not you do the tests, the principles are really relevant. Perceivable, for example, the way you would think about it is with 2 questions. Can somebody, I'm building something like a charter graph, can somebody perceive this in multiple ways? And is each way easy to perceive? Those 2 simple questions. Many of the principles follow that same pattern. So improving data visualization tools using chartability, the first thing, oh, I guess.
Yeah, okay.
Sorry.
So we started with working on Bokeh. Bokeh is an interactive data visualization library that targets web browsers. So this was a good Python library to start with because it was translating the code and data into graphs that are for web and rendered in an HTML-friendly format. So we could already leverage things like WCAG and the Web Content Accessibility Guidelines. Same thing, but yeah, for it.
Yeah. Bokeh was a perfect sort of context for us to explore accessibility in a Python visualization ecosystem. So what we did, the first thing you should do is if you have this question in your head, well, is something I'm building inaccessible to people? You need to be able to know how to recognize a barrier, whether or not you've made a curb, right? And so that's what Chartability helps you do. It helps you find all the curbs, well, a lot of curbs in data visualizations. And what you do is you perform an audit or an evaluation. And an audit is just a fancy way of saying it's a systematic, documented way of performing an evaluation for accessibility. And I'm going to do a couple demos. So we're going to go over 2 things out of 50 that exist in Chartability in a real live environment. And we're going to start with the principle perceivable. So if you remember, there are 2 questions. Is this thing perceivable in more ways than one? And is each way easy to perceive? So we're going to focus on this second, easy to perceive. We're going to specifically look at probably the most impactful single thing you could do for design and visualization is contrast or color contrast. Go to the next slide. So this is our dashboard. Before I talk about contrast really quick, I want to talk about what's called a situational limitation. So earlier I mentioned we all benefit from accessible technology. Sometimes it's invisible. Well, if you go out into the outside world and it's a bright day, you're thankful that your phone automatically adjusts. Well, a bright day is a situation. And giving a talk is a situation. When you look at a chart on your own personal computer, you're very close to it. And then when you give a presentation, I bet the people in the back of the room might have a hard time even seeing what's here. So I've produced a situational barrier for everybody in this room because this is hard to see. So I'll just bump it up. Again, an accessibility feature that's very simple that we can all benefit from. So this is just a dashboard. Being able to look at it in detail isn't necessarily important, but this is the thing that we built in order to audit. So we're going to be talking about a tool. This is a manual checking tool for color contrast. It's a browser extension. It's called Bokeh Color Contrast Checker. And I've just added it to Chrome, and I'll just show you how it works. So in order to evaluate contrast, you want to be able to look at something in a foreground against its color in the background. And are the 2 things distinct enough to be perceivable, distinguishable? And that's what contrast is about. So we'll look at this bar chart. I'm going to open my browser extension here. And there's 2 color dropper slots, one for the foreground. So I'll click this yellow bar. And then the background, I'll just double check. Sometimes whites are off-white. This is pure white, though. So what we see now is these 2 colors have contributed to a score in the bottom left of my screen. Small says contrast 1.26, AA X fails. We want to hit AA. Large 1.26 AA also fails. We want large. Geometries and heading text generally fall under that category. So a bar chart should have more than 1.26. We could check the color of a darker bar, like this dark blue here, and it passes, 6.09. We want at least 3 or higher. Now, creating high contrast visualization color palettes is very hard because we like to visualize. In this color palette, it's very common if you visualize data in Python. We have a light yellow, and we go to a dark blue. So what we're doing is changing hue and luminance, or brightness. Luminance is what we use to measure contrast. So it's pretty hard to make a palette with a light minimum color that will also pass contrast. So there's other techniques you can employ besides just changing your colors. We'll talk about that a little bit later. But for now, just know that this is sort of a very brief introduction to contrast. I also want to note what we're going to do here is I'm going to go over, we're going to color dropper. You also want to color dropper interactive stuff. We're going to go over to this button. We're going to check the gray in the button. And remember, this also should be 3 to 1. It's 2.46. Now, when you're an author of a visualization, you can change the color palette. But if you use a tool like Bokeh, very hard to change the color of the buttons that come out of the box. So sometimes, as a user of a tool, you have control over some things and not. This is also a reason why we thought it was important to work with the Bokeh team directly on this. So back to this. Next demo is in operable. Exact same framing as perceivable. Can I operate this in multiple ways? And is each way easy to operate? So we're going to be using a screen reader. Some folks maybe have never heard a screen reader before. It might be your first time. I hope the introduction doesn't spook you too much. They're really not that scary. Some folks are really intimidated by them, though. But screen readers should be able to do everything that a mouse can do. But the trick to a screen reader is they navigate using what's called the keyboard API across a web page. So you can test something with a keyboard, but you should also test with a screen reader. So we're going to get a screen reader out, and I'll show you. There's also a close tie between perceivable and operable. You need to be able to know something exists in order to operate it. So I'll show you what I mean. All right, let's close the contrast. We'll go up to the top. I'm going to turn on a screen reader. It's going to have synthesized audio. It might be a little loud. Just bear with me.
Voiceover on Chrome. Bokeh.
Okay, that's the synthesized speech. If you have trouble keeping up with the audio, on the screen there is a little caption bubble of what's being said by the screen reader. I'm just going to skip ahead into the chart right now.
Entering Bokeh dashboard for accessibility audit web content. Link. Data table using the box end of list. Your image. You are currently on an image. Inside.
Okay, we've made it to our first chart, and it says image. Not good. No alt text. I'll keep playing the audio so you can just hear the rest of this.
Side of web content. To begin interacting with the contents of this image, press Control, Option, Shift, down arrow. To exit this web area, press Control, Option, Shift, up arrow.
Okay, sometimes images contain things, maybe more information. All we know is this is image. We don't know the heading. We don't know that this is bachelor's degrees in engineering earned by women over the years. We don't know it's a line chart. But let's go inside. Control, Option, Shift, down
No
arrow.
visible title to interact.
Nothing. It's empty. All right, let's keep going forward.
Image. You are currently image. You are currently on an image. Image. You are pan. Empty group. You are
Interesting. So the first whole part of the page just skipped over everything. It's all images. But now, interestingly, we're in this interactive portion on the side of the chart. Well, let's see. Can we use these buttons? We're going to go down to the download button here and just see what would this sound like to a screen reader user.
box zoom. Empty box select. Wheel zoom. Save. Empty group. You are currently on an
Okay, it says save. You might think that's good enough. This button says save. Oh, awesome. Except it doesn't say it's a button. It just says the word save. So in making things accessible for screen readers, you need to have semantics. A screen reader user needs to know that a thing is interactive, or is it just text and words? So this should say, if it's a link, it should say link. If it's a button, it should say button. But this is made with a div element in HTML, which is essentially just an empty semanticless element. So a screen reader user cannot perceive this save button, even if they wanted to operate it. Unfortunate. So this would be a failure, of course. All right, I'll exit the screen reader.
voiceover off.
Encourage everybody to try out screen readers. You'll realize everything you've ever made in your life, if you've never used one before, grossly inaccessible. It's a good exercise and humbling, and relearning kind of basic building blocks, too. Okay, so what we did, that was 2 things out of 50 in Chartability. We did the other 49, and then we repeated it 2 additional times. Bokeh is a big ecosystem, so we kind of broke it into 3 separate kind of sub-ecosystems. We performed 150 total tests. So all of our findings, including a summary of like what does this all mean, as well as what are next steps, we've summarized in an audit, and we've put it out publicly. I highly recommend, especially if you're a tool builder or maker, you work in an ecosystem, and there's people downstream from you who build with something you've built, check this out, look into it. Start the steps moving forward, because Python is very behind other ecosystems, and I really want you all to catch up. We hope this is a helpful resource, especially. Okay, so the next thing we want to talk about is what are some actual practical tips. Maybe you're not a tool maintainer, but you want to make your charts and graphs better.
Yes. We'll go through just a few quick things you can do. So let's start with a sample plot. So this is a multi-line plot, but it is not usable because it does not have, it's not complete. It doesn't have a title, legend, and axis label. So before we even move on to making accessibility better, we want to start with a complete graph. Before we go into accessibility, I do want to share something actually I learned from Frank and other accessibility experts. By creating data visualization, we're already making our raw data more accessible. So we've already taken that first step. So the next few things are just building on it a little bit. All right, so we have a complete graph. And we have used 2 different colors to indicate engineering and business. But if you look at this same graph in grayscale, these colors don't look as distinct, which is why we don't want to convey information primarily with colors. We add texture as well. So this is looking a little better. Something we can do further to improve it is increase the line width. This makes the graph more perceivable to everyone here, like on a slide, but also this is like the default width that we had earlier. If you have an interactive tool with a hover tooltip, it's going to be really hard to hit a very thin line. So we do want to have just adequate line widths. Now, next up, Bokeh is an interactive visualization library. So actually, let's go back to the dashboard. All plots have some default plot tools which give you interactive features. So this would be something like a pan, which lets you pan in a graph. Yeah, we can pan and zoom in and out. But in this particular plot, there is no extra information we are conveying. In fact, a user can end up in a part of the plot that has no information. So for this particular case, we can actually disable interaction because all the information is right here, and just leave a save and help tool available. So with this, we've made this graph better, but it's still only usable by sighted users. So the next best thing we can do is write text. Do you want to take a little bit? Yeah.
A note that I just want to say that it's ironic, as somebody who visualizes data, we're trying to get away from data. We're trying to get away from text. It's very hard to look at tons of text and find any value in it. So we visualize tables of data to make summaries quickly. Well, it turns out we do have to return to text a little bit. Having text-less charts actually is really inaccessible. We have a lot of studies on text in visualization aren't even focused on accessibility, and business executives, people that are in a hurry, people who are learning, all benefit from just clear labels, clear titles, clear captions, good summaries and descriptions. So whether you're trying to capture the attention of somebody who needs to approve a budget for you, or you're teaching students, you'll have more memorable, better visualizations by returning to text just a little bit.
So with that, let us write some text descriptions for our sample plot. And this is a nice framework you can use to write text and like good descriptions. So this involves just thinking in layers. We start by like bottom to top, starting with just the high level, what the title is, what the axes are, what's the main statistic being conveyed, and then slowly moving to more context, why is this statistic even being observed? So we'll go through a full example, and heads up, this is going to be a text-heavy section, and I'll be reading out everything on the slide. All right, so let's go through this exercise one by one. So first, we explain just the high-level context of this plot. This is a multi-line plot titled Bachelor's Degrees in Engineering and Business Earned by Women from 1970 to 2011. That plots the number of degrees earned each year. And if you really want to try, you can also close your eyes and just listen to the text and see if you can visualize the whole plot. So we start with the title, axes, high-level things. Next, actually, we haven't finished the axes yet, so let's talk about the axes. The number of degrees is plotted on the y-axis, ranging from 0 to 50, and years are plotted on the x-axis in 10-year increments. After this, the main statistic, giving a summary of what matters. Degrees earned in business are overall higher than degrees earned in engineering, and the gap increases from 1976 to 1984, then remains consistent. And finally, a deeper description of the same data being conveyed. Engineering degrees start at 0, reach 10 in 1980, then increase to around 18 by 2002. This is a slight dip, but the number of degrees stay between 15 and 20 till 2011. Business degrees started around 10 and rapidly increased to around 46 by 1984. It then gradually reaches 50 by 2002, followed by a slight dip to 48 by 2011. So this is, we've almost reached the end, but what this is, there's a next step, which is giving a subjective explanation of why this, why we see this specific statistic. This is sample data, so we haven't included that here, but for any real data, you want to add some more contextual ideas there. And finally, even after all of this, one of the best things we can do for accessibility is share our raw data, which just gives people more ways to interact with it, in addition to the visualization we shared. This can be as a table, as a CSV file, and however else you want to share it. With that, I want to give a shout out to our team. So we just shared the initial audit we performed for Bokeh, but there's a lot of work now to incorporate the, improve Bokeh based on the audit. So we have a large team from QuantSight, Anaconda, we have Frank. And this work was funded by the Chan Zuckerberg Initiative's Essential Open Source Software program. So thanks to them, we could do all of this wonderful work, and thank you.
We have time for questions, and there are 2 mics at the back. Well, I guess just one now. Please feel welcome to step to the mics and ask questions. Please keep them brief, topical, and make sure they're actually questions.
Thank you.
Not working yet?
I think they're running over right now.
Maybe this one works? Okay, yeah, sweet.
Okay.
Yeah, I just had one question. So how can the WCAG, sorry, I'm saying that wrong, extension on the Chrome browser measure the contrast of a single color picked by the dropper? I was kind of under the impression that contrast is like a measure of a color relative to its neighboring colors. If you could just provide a little clarification, or maybe I'm misunderstanding something.
Oh, yeah. It does do 2 colors. It is
Oh, okay.
2 droppers, one against another. Yeah, and so you can use that for things that are adjacent or something on a foreground or background. Yeah. And if you want to talk more about color, hit me up afterwards. I'm very passionate about color contrast algorithms, spent years in that, so
Sweet.
yeah.
Thank you so much.
Thank you.
Do you ever consider content or register as part of accessibility when you're presenting data?
What was the second, content or?
Register, like the register of your language, how technical maybe that is when you're presenting data to a particular audience.
Yes. Yeah. Short answer. Yeah. Thanks. No, absolutely. So understandable is a principle, and it's very important. So there's a few things at play here. One is that there's an intersection between language and disability in general. So you can be situationally limited if there's a difference in language, even a difference in accent in spoken context. So even just at that level, yes, it matters how we communicate. But in WCAG and Chartability, there are tests for understandability. So basic kind of cognitive tests for reading level, clarity, and some other things. So yeah, it's vitally important, I think, especially because we're trying to communicate with data. Yeah, great question.
Thank you.
This is going to sound a little bit paradoxical at first, but are you aware of any, not even standards, but people who have done anything with accessibility for dyscalculia, disability with numbers?
Mm-hmm. Yeah, there's some research in that space. It is not, as far as I know, integrated into any standards. So it's a good question, I think, because it allows me to talk about how standards will always be behind whatever knowledge we're currently uncovering. Standards move slow. They take 10 years, sometimes 20 years to get into place. So the short answer is we've got good research coming out on dyscalculia, but nothing in standards yet.
Thank you. Thank you.
Thank you.
Hi, I'm curious about the configuration of your screen reader. Can you speak to how common it is to have that speak so quickly? Is that like a common thing maybe because you're surfing and trying to get through the framework of the page?
Great question.
It clicked, you know, but it kind of took me a second to catch up with what it was saying, so thank you.
Oh gosh, good question. And actually, that's great because, again, a situational limitation that I put on all of you is a screen reader that is actually, I slowed it down for the presentation. Yeah, so people who work with screen readers, especially people who we call native screen reader users, they use it as part of their daily life, whatever. They listen much, much faster than that. It is almost incomprehensible if you don't have a trained ear. And I would also be happy to talk about synthesized speech algorithms afterwards because it's an interesting space. But that being said, as a personal note, I will slow it down a bit next time. It is faster than the default, so I should probably use default. But yeah, thank you.
Hi. So I work on Plotly, and something we've been looking at recently is sonification. Sonification of charts, and I was curious if you know much about that, how much it can help people. Yeah, we've been curious about it.
Do you want to take one?
Well, we haven't been working on it on the Bokeh side. If you have some general ideas, Frank, about sonification, maybe we can share that.
Yeah.
Yeah, because I mean, it has been identified as potential, but right now it's just not, we have higher priority items to work
No,
on.
totally,
So
yeah.
that's the main thing. But I mean, if you have ideas, we'd love to, you know,
No, we'll
borrow whatever
definitely
you all
talk.
decide. Yeah.
Yeah. No, I was just curious because it was unclear to me how much actually low vision folks like would benefit from that, and I was just curious if there's kind of research into that.
Yeah, low vision as separate from blind is a category difference, just as a reference. I don't know if you meant low vision versus...
Both, yeah.
Okay, yeah. Blind, there's studies that date back until the 80s. I think the moment we could create synthesized audio on computers, we started playing around with this for accessibility. My suggestion, because I love that you're working on it, is, I guess this is our last question also, is look to libraries that have done it already. So Erie is a sonification library that's very good. Charts has a sonification studio. And then lastly, I would say Apple's Audiographs. So I was at Apple for a while and worked with their team. So those three have done really great work. So if you at least want to jumpstart some of the design thinking in that direction, hopefully that's helpful.
I'll talk to you more about
Awesome.
that after. But thank you.
Hey, I'm just like wondering, what about like using machine learning, like all the ChatGPT, all that, to read like charts and stuff like that? And
Yeah.
because you can like literally like post a picture of a graph to ChatGPT and it can give you a pretty accurate description of what's happening there. So why can you like add it to like a screen reader or
Do you want to
other ways?
I can start.
Ask for the answer to be brief.
We'll keep it brief.
What do you think about it? I guess, yes, there is some promise there, but I think it just needs more looking into and more dedicated effort to, you know, see actually how accurate it is. Like, it looks accurate for the couple of plots we've tried, but there are just, as we showed earlier, there are so many different ways data visualization is used. So it needs to work for all of those cases, and that needs a little more work.
Yeah.
What about you?
The only thing I want to add is that because of hallucinations and because you're producing descriptions, it is especially an ethical problem area, because there is no way for somebody who is blind to verify the information if there's only a generative model. So in an ecosystem where it's the only thing, it's high risk. You put people in trouble, and especially with data, we don't want to take risks. So yeah, would love to chat more. It's one of my big passion things that I love to talk about. So, but thank you.
And with that, thank you to our speakers.